Engineering Review 103, Specific Resistance and Ohm's Law. Specific resistance of a material may be defined as the resistance offered to a current if passed between the opposite faces the unit cube of the material. It is measured in ohm cm, Ohm's law. According to Ohm, when a voltage V is applied across a conductor, then current I flowing through it is directly proportional to the applied voltage. Voltage divided by current equals constant. This constant is called resistance R of the conductor. Hence, Ohm's law can also be defined as the ratio of potential difference between the ends of a conductor to the current flowing through it is constant, provided physical conditions do not change. Conditions for Ohm's law. Ohm's law can be applied either to the entire circuit or a part of a circuit. When Ohm's law is applied to part circuit, part resistance and the potential difference across that part resistance should be used. The Ohm's law can be applied to DC circuits as well as AC circuits. However, in case of AC circuits, impedance Z is used in place of resistance. Limitations of Ohm's law. Ohm's law is not applicable under the following conditions. For metal which get heated up due to flow of current through them. For electrolytes where enormous gases are produced on either electrode. For vacuum radio valves. For arc lamps. For semiconductors. For gas-filled tubes, in which the ions are generated as a result of current flow. For appliances such as metal rectifiers and crystal detectors, in which the operation depends on the direction of current. Thank you. If you have any more questions or need further assistance, don't hesitate to ask. Happy learning, and have a fantastic day.